could put strange conversations in the background.
Oh, well, it's on right now. So, anyway, so we start with the matrix 4, 1, 1, negative 3, and 6, negative 3, and we're transforming it. Yeah. Oh, oops. Let's go back. Okay. We're transforming it by adding it to this matrix, which is 2, negative 3, 2, negative 3, and 2, negative 3. And when we do that, we should get 6, negative 2, 3, negative 6, and 8, negative 6. And when we look at matrices that have 2 rows, we know that each column is going to be like an ordered pair. That was big. So we have the first row being our x's and the second row being our y's. So we can make these a bunch of ordered pairs by saying each column is its own ordered pair. So we look at it, we have 4, 1, 1, negative 3, and 6, negative 3, like we said earlier. So when we set all these up, we notice that our before image and our after image are different. And what we notice is that they go 2 to the right and 3 down. So yeah, these are the before and the after ordered pairs, and this is the before triangle, and this is the after triangle. In our second problem, we start out with the matrix 4, 1, 1, negative 3, and 6, negative 3. We transform it by multiplying it with the matrix negative 1, 0, 0, 1. And when we do that, we do the row by the column, I believe. And so we'll multiply 1 by 4 and add that to 0 by 1, because that's this. Oops, that was big. That's this row by this column. Row 1 by column 1. Yeah, looks right, I think. So then we do that all and we get negative 1 times 4 plus 0 times 1 over 0 times 4. I'll cross out. 0 times 4 plus 1 times 1, then negative 1 times 1 plus 0 times negative 3, 0 times 1 plus 1 minus 3, negative 1 times 6 plus 0 times negative 3, and then 0 times 6 plus 1 times negative 3, and we do the multiplication part of that matrix and get negative 4 plus 0 and 0 plus 1, negative 1 plus 0, 0 minus 3, negative 6 plus 0, 0 minus 3. And then we do the addition part of that, and we get the final matrix of negative 4, 1, negative 1, negative 3, negative 6, negative 3, and from our previous problem, we know that our first row is the x row, and the second row is the y row, and each column is an ordered pair. That's off. Each row is an ordered pair. Column is an ordered pair. So we get, when we plug those ordered pairs in, of like negative 4, 1, before triangle gets reflected over the y-axis right here. So we know that we're multiplying all of our x's by negative, or changing the sign on our x's, yeah, because when you change the x's you flip over the y. Sounds good to me. This is fun. Hope that was good.